happy to introduce James Harley, a Canadian composer who teaches at Guelph. James's work has been performed in Canada and around the world and won many national and international awards. He also writes extensively about music. I'm personally very excited to hear about how mathematical ideas play a role in Xenakis' work, particularly random walks and Brownian motion. So I'm extremely interested to hear this.
Thank you. I wonder if we can turn the lights off, maybe. I noticed that this font isn't great for reading, so if anything we can do to... Yeah, that's a bit better. You don't need to see me. You need to see the slides. Yeah, maybe a little. That's not bad. I mean, it's a bit better. Pardon? I can hear it. I'll speak up. I will speak up. Thank you, and thanks to Ed and to Ayun for organizing this and inviting me. It's always a pleasure to get to talk about Xenakis. I felt a little intimidated. I have to say, I'm not a mathematician. Sharon this morning reminded me of, like, Xenakis would, I didn't spend much time with him, but he did recommend that we learn about mathematics, and I remember I still have some of those Sham mathematics books. Finite mathematics was the one he recommended, and I actually did work on it, but I wouldn't pretend to be fluent in that stuff. But I figured it would be useful to sort of talk through some of the techniques that Xenakis developed for composing music, and some of these, and at least to mention, and others in here who know a lot more about the math than I do can fill in some of that. One of the things that I find interesting in terms of, and maybe it's me being naive, but Xenakis learned math because he was an engineer. He might have learned some as a school kid, but as a professional, he studied engineering, and so he used probabilities as part of the analytical approach that they needed for engineering, to figure out, to try and calculate loads and all that kind of stuff. And so his job when he started working for Le Corbusier at first was running calculations of probabilities and so forth. And but what was interesting, or what strikes me as interesting, is that he turned that around. So that the mathematics is those are sort of analytical tools that people work with to understand the world better. What Xenakis did was to turn that around and say, let's use these tools to actually create something, not to understand the world, but to create something new. And so that sort of turned all of that around. And he probably wasn't the only one, but he certainly was one of the first and one of the main ones. It is interesting, as Sharon was saying, that he did study engineering and then got into architecture. The other person who sort of in the 50s worked on developing algorithmic and computer programming and applying some of these mathematical tools to music was Leger and Hiller, who was at University of Illinois at Urbana-Champaign, and he was a chemist, and he was using those tools for one of the early people using computer tools to do analysis in the chemistry world. And then it struck him that maybe you could, again, turn these tools to generate new things, like new music. So Xenakis, coming from his background, Hiller coming from his background, they both were using these tools, and eventually using computers, which was also new at the time. The other main computer person was Max Matthews, who was also an engineer, but an electronics engineer at Bell Labs. Anyway, So, Sharon has filled in lots of the sort of life stories, so I just mentioned quickly. When Xenakis was first, this is not a great slide, but it does show it with metastasis his, applying sort of geometrical processes to generate music, and at the same time applying these ideas to architecture, which was also something new for him to be getting into at that time. Le Corbusier gave him more autonomy and more creativity in his studio, and he actually did do some architectural work. And this slide shows the connection between these rules glissandi for strings that he applied in Metastasis, and then the design for the Phillips Pavilion from 1958. And it is worth noting that nobody had ever done this before. That opening of Metastasis, I know that Sharon mentioned that Pithaprocta was maybe more innovative in some ways, but really nobody had done anything like this before. So when it was performed in 1955, 54, it was 55, I guess, it was a shocking thing to hear, because there had been no music ever that sounded like this. So that's quite something. Doesn't happen very often. Anyway, Pithaprocta, Sharon mentioned, and it was much more application of probability theory, of techniques from probability mathematics to generating the music, especially these kind of statistical mass textures that he created. Now, this sketch, which is also out there on some of the posters outside, I think that lasts a few seconds. And it's thousands of little events and he calculated this all by hand. Exactly the placement of all the events, how long they would last, where they would happen, what the pitches were, and in this case the glissandi. He had to he was using probability tools. He did it all by hand, and that was this was probably the point, maybe even this moment when he was working on this piece, when thought, gee, computer might be useful, might be really useful for saving some time. And so even as early as 1956, Xenakis started to think about the use of computers to do some of these things that were really time consuming. Along the way, he did try and develop a formalized, just in thinking through what music is, what it could be, and how he could apply some of these tools that he was familiar with from his background as an engineer, especially to music. And so early on, and we have to remember that this is very early in his development as a composer that he started to do this, and really there wasn't anybody else. The prevailing formalization of music that was going on at that time was serialism. So the other composers in Darmstadt and in Europe that was the main thing that people were exploring, which in terms of mathematical is really simple. And he criticized that approach because the music did become really complicated, but it was all very sort of deterministically created. But when you listen to it, it was too complicated to understand. And so he realized that applying statistical tools would be more sort of more real, in the sense that the music, the way we perceive it is relatively statistically, and so why not use statistical tools, probability functions and so on, to generate it, rather than create deterministic linear structures that nobody would be able to follow because it's too complicated within an orchestral texture or whatever. So he, hopefully you can see this. This was his first attempt to kind of formalize music composition. And he did in his book, Formalized Music, which Sharon had on display, and you can consult if you would like, he developed some algebraic some algebraic approaches for a number of these steps in what he considered the basic stages of what you needed to do to compose a piece of music. What I find interesting is that there was lots of misunderstanding because he used mathematical language to talk about his music quite a bit, which was off-putting for the music people who didn't understand. If he just put a probability function into a program note, it would be off-putting for people who go to concerts because they wouldn't understand anything about it. But he didn't ever presume that the formalization would not include intuition. So I wanted to emphasize that, even though we're talking about some of these sort of formal techniques, that in his early thinking about what music is, his initial conceptions is primary. So, and I heard him talk about this in person as well, that you have some idea of what you want to try and do in the music, and the techniques are to help you do that. It's not just running techniques and generating music. He applied this by hand, again, in this piece, Acaripsis, from 1957. And this little sketch, there's another one outside on one of the posters that's a little more detailed, but it was sort of his chart of the form of this piece. So as part of his formalization process, he decided that music would have a number of sections. And then you get this grid, and the rows in this are different instrumental, or what he sometimes called sonic entities, or in this case, because this isn't for an ensemble, they're different groups of instruments. It's not easy in this sketch to see, but the top one is flutes, which really means flutes and clarinets, sort of single reed or along with flute, and then if I can read this, oboe and bassoon is the second one, glissandi, string glissandi is the third, percussion, pizzicato strings, brass, and then bowed strings. And so those were his sort of categories of instrumental groups or sonic entities. He used this term sonic entity because he did, and Sharon had also mentioned this, he didn't see any difference between instrumental music and electronic music. So a sonic entity could be a sound that's created in the studio. It could be a flute or a percussion or a glissando, string glissando or whatever. The main thing that distinguishes these sections, and in this particular piece, he arbitrarily decided that each section would be 15 seconds long. So they were fixed for this one, and then he sort of filled in what essentially amounts to density charts for each of the instrumental groups. And they're not exactly 0, 5, and 10, but they're within that range. So that would mean that there would be different amounts of different number of events happening within this 15-second frame, and specific to these instrumental groups. So I'll play this, or can. And you can maybe follow along. Oh, there we are. Stop there. You follow that, right? Easy. Now, so he's using what he called stochastic functions to make the decisions about when something would happen within this frame of 15 seconds, when and what it would be, like which pitch, how long they would last, etc. Those are all, he's using probability functions to make those decisions. What's interesting, I mean, that was a lot of work, and nobody done this before. But of course,
between the image and the stochastics?
Well, the image is just showing a global plan. So the stochastics would be, if we broke that down, say the first column, we've only got pizzicato at a certain density. So approximately, what does he say? Approximately 5 events per bar. So per 2 seconds. Each bar was 2 seconds, I think. I should have the music score as well. But so that was his guideline for the section. So he's got pizzicato. He wants to have about 5 of them happening every bar. So 2.5 per second, I guess you could say. And then the stochastics are what he uses to decide exactly where those, say, 5 events will happen in the bar, which instrument would, which pitch it would be, and etc. So he had sort of decide, okay, this is my, so, and I've got to, use some kind of probability function to determine where the events would happen. And, if you analyzed it, it would be statistical kind of, it could have been different, I guess is another way of putting it. Using the tools that he created, he could have written another score that would have the same overall plan, but the details would be a little different, or even a lot different. But what wouldn't be different would be the overall number of events per unit, statistically. So this, in order to do analysis, and there are people who've done this, Linda Arsenault, I think, did her doctorate basically trying to reconstruct this whole thing and run all of the processes and try and trace it right down to the actual details. But the details are what this isn't showing, just the overall kind of plan. Well, what I was going to say was that was a lot of work, conceptual work that nobody done before. What he didn't think about for this piece was if and as composers usually would have, this was a radical departure in a certain sense, that he didn't actually have any kind of plan to connect one note to another. So the choice of pitches, which notes you hear, is randomly generated, and there was no other overall guidelines for that, aside from that the pitches had to fall within the range of the instruments. But otherwise, that was a random stochastic process that he ran with no other guiding compositional process for that in this piece. So when you listen to it, at least when I listen to it, what you're essentially settling on, once you realize that there is no connection between the notes, there's no like row unfolding or a melody or anything. It's a pointillistic piece, individual events that you're basically listening to the flow of the density of events per section. because there's not much else to. There's no regular rhythms. There's no pitch organization that is anything beyond statistical. And he didn't. He did. I mean, wanted to get to the point where he actually does think about those things later. But this was a lot to conceptualize and implement, especially by hand at the time. So he did it, and it works. It's not a long piece, but what's interesting about it is, even though nobody else was doing anything like this, the fact that he was creating essentially pointillistic textures where it's individual events that you hear and that create a global kind of effect, was kind of not that different from what other people were doing, but they were using other techniques like serial techniques and so forth. This pointillistic style was common to other composers in the 1950s especially, but he had a completely different way of doing it. And now, like I said, he realized that doing this all by hand was really time-consuming and unnecessary if you could get a computer to do it. So he started to learn computer programming in his spare time. Remember that he was working full-time for Le Corbusier through this period. And by 1962, he had learned enough programming. Fortran was the language he learned, and as Sharon said this morning, he got a little bit of time on a computer. And when I talk to students about this, it's just a weird concept to think that in Paris there was one computer in the whole city, and you had to pay a lot of money to have any time on it. And it was IBM, and that was their business. They had the computer. People came to them to run programs or whatever. Xenakis had befriended somebody there who was able to get him in, and I'm assuming, any of you who've done computer programming, you realize that at that time, given that an hour was very expensive, that he would have had to have his program, his punch cards or whatever he was using at the time would have had to been as close to flawless as possible, because if you know how it is, if you forgot a semicolon, then your program fails and it kicks it out and you got to go back and do it over again. So I'm presuming that he had some guidance that would help him to get that together before he got the time on the computer. It's not like it is these days where computers are everywhere. And but he did, and he succeeded in 1962. He had a few access to, and he was able to run his essentially his formalization of what he had started thinking about in 1955 or so, and generate some data which he then transcribed into musical notation. And he goes through, this is a sort of reformulation of his basic steps for what you need to do to create a composition. Again, he treats it as his point of departure is that you have a number of sections. For this algorithm, he didn't fix it at some, the sections could have different durations, and that was generated by a stochastic function, the decision of duration of sections as well as just about everything else. Again, he defined the sonic entities or the orchestral, the instrumental categories, and then fixing everything else. So he had to get it into a form that could run on a computer, and then he got some output. It would have been numerical data of some kind, and then he transcribed it. Here's a bit of his flowchart from Formalized Music, where he was sort of developing parts of his decision process. This is this was for one of his pieces, one of the runs that he had prepared to run through the computer, where he's defining these sonic entity categories or instrument groups, and he includes things like glissandi, where he now, if he's got a trombone, he knows that a trombone could play glissando, so that could be factored into that category. Tremolo or flutter tongue was a separate one, and so forth. So it's interesting the way he was thinking in terms of the kinds of sounds he was interested in including. Again, the overriding determining factor for each of the sections, which he considered fundamental to a composition, was density of events per section, however long that section might be. And we heard ST4 today at lunch with the Jack Quartet playing, and that's like, there's a lot of, it's a very complex piece, and but what you hear, if you don't pick up other details, what you do hear is that it opens with a ton of events, and then they ease off. So there's another section which has a lower density overall, and then it goes like that. It's interesting that Xenakis, and Sharon mentioned something about this as well, that the end of his process wasn't to run the algorithm. It was to get data that then he would use in composition. And so he was happy to manipulate the data to suit his own purposes if he felt like it. Like, one of the things that he does is to mix up these sections. So he's got these overall densities for each of these sections, and then he runs it and he gets the results, and then he decides, oh, section 14 actually would be better if I put it after section 16. So he mixed them up a little bit. Not much, but he did, which is interesting. And then as the Jack Quartet were saying, in the concert, for this particular piece, ST4, that they played, he actually, it was actually not a separate run of the computer algorithm. It was the same run, the same data as ST10, which he then said, okay, what can I take from those 10 instruments and cram into, so that 4 instruments could do it. And it's an interesting comparison to look at the two scores. Actually, I thought I'd play a bit. We heard ST4. Here's ST10. Remember that spot where the strings are drumming on their instruments? That's the transcription of the percussion part. Why not have violins drum on their instruments to cover for the percussion part? But of course, actually, in Pitta Prakta, which he had written in 1956, he already had the strings drumming on their instruments as strings. So it wasn't that this was just a kind of a, well, I'm going to try and transcribe this percussion part for strings. It was that he already was using that kind of a technique in the earlier piece. Just now, the one that was a separate run, and I'll just play a bit of this, is the orchestra piece, ST48 for orchestra. So the data is different. The density of each of the sections is different. he continued this a little bit. These pieces, Atre, which I think was partially generated from this data from the computer run, and I think parts of Aonta from 1963 with a piece for brass and piano. And then he put this aside, or at least, he decided to pursue other things. And one of the things that he was interested in, then he'd done a little work, skipping over some of the things that he was doing. Sharon had mentioned games. He'd also tried to explore Markov chains to try and get some kind of connection from one note to the next, a mathematical connection. He'd done a little bit of exploring of that. But he then did decide to put some attention to deterministic. So this was all of the music is being generated what he would call stochastically. So using probability functions to make all of the micro decisions of the music. And so he sort of then turned his attention to deterministic techniques. And what he called theory of groups, and I'm really no expert in this at all, but essentially it was to try and develop a technique or procedure for creating orders of events that could be specific details of music like notes or rhythms, durations, or else of larger sections. He used as a model, a geometric model, like this tetrahedral shape down at the bottom, which he then sort of analyzed the different ways it could be rotated inside of a cube, and he used those as basically the boundaries of his possibilities for making these kinds of choices. And he developed a kind of a matrix that he used just those possibilities to guide decision, like a sequence of decisions which could be attached to, like I said, all kinds of different musical parameters. But obviously it's limited. It's not random. There's no random element to it at all. So it's quite a departure. But he developed this kind of technique, and he applied it to a few pieces at first. Nomos Alpha for solo cello is the one where he wrote about informalized music and sort of presented as much of the information about all the decisions that he took as he could. And you can read about it there. The first piece, really, though, was this piece for a wind ensemble called Akrata, which was sort of, he was applying maybe in a more rudimentary way this idea of groups and sort of applying the decisions about pitches, about the sequence of events and as the music unfolds, and so forth. Just play a bit of this. It's quite a restricted, basically the piece is about held notes or repeated notes. There isn't anything else. Actually, there is something else. Silence, I meant to mention. Xenakis has an interesting relationship with silence, and where he doesn't use silence as a way to define boundaries between different events. He uses silence really as an equal to other things going on in the music, so that in lots of his pieces, you will find a silence just suddenly appears in the middle of something else. And it's significant, I think. It carries a lot of weight, and it really doesn't just convey that we're now going to go to section 2 or whatever. It has carries its own kind of force. And And he does incorporate it into his thinking, so that in terms of working out, say, a plan, like even back in achorypsis is possible. There's at least one of those columns where there are no events. Although that statistically means there might be occasional event in 15 seconds, but basically he's thinking there's a density of 0. But that's just as important as any of the other sections or other densities. So it's an interesting kind of take on silence, and connects him, I think, in a way to John Cage. And I think that more work should be done on that connection. Very different approaches to music, but some similarities. So Nomos Alpha was the one where he really rigorously applied this theory of groups, so a very deterministic approach, but quite complicated, with different levels of decisions and different parameters organized in different ways to produce a pretty complex texture or complex music. But complex formally, I mean, it's not just, and where there's a lot in the music that goes beyond just density. I'll come back to a little bit more, but I'll just give you a taste of this. Oops. Whoa, I lost it. One of the things that I would point out, if you can see that at all, is that there is still in this music, even though it's much more deterministic, it's one of the things that is I'd say maybe even the most important element is what I would call sonic entity. So he's creating a series of possibilities of the kinds of music that the cello can play. So glissandi, tapping with the bow, etc. There's a whole, it's a huge sort of list of sort of sonic possibilities that this solo cello can do, and that's one of the primary determinations of the form is the succession of those things. And then, of course, there's register, there's dynamics, there's the actual pitches that are used, etc. But this idea of and through all of Xenakis' theorizing, pitch isn't as important until at first, at least. It's that you can have music that works really well, it's very powerful, where pitch isn't necessarily the primary thing. And in most music up until Xenakis, it is the primary thing. So this was another kind of radical take on music that he was implementing by thinking about what the possibilities were in a more general way. So what is this kind of more deterministic theoretical work has some consequences. I don't have time to get into it, but it's it becomes sort of multidimensional. You've got a sequencing of different parameters that are all getting unfolding in time in different ways at different rates, independently or not. So it's quite a rich approach to musical form, I would say. It led him, I'll come back to this, I was going to just say that he led him to this thinking about time in relation to music, that some some elements, and he develops a whole, there's quite a long development of this thinking in formalized music, where outside of time, some things, some relationships can be expressed outside of time, some expressed inside of time. And all that really means is, like, the example that I often use is, when we're thinking about traditional music, say that, there's a piano sonata in C major. C major means that there's a set of, there's a scale that the music is based on, but the scale isn't presented, in order, in time. We realize it over time, but it's not. The relationships that are inherent in a major scale are outside time, because they're not presented in the music in some kind of sequential way necessarily, but yet the relationships are still there underneath the music. So he was trying to generalize that, so that's kind of encapsulates his idea of outside time. So some relationships can be worked through in that kind of way. Some would be, of course, the unfolding of the music in time is important as well, and some relationships are worked out that way, and then the actual score itself, which is kind of the manifestation of all of that, is what he called the temporal form. Now, let me just go back to the other thing that he worked on at that time, which was his sieves. And this is the way I understand it. It's more complicated, but I'm not a mathematician, so I try and boil it down to something I can understand. And he talks about this in sort of the formalizing, essentially, an ordered set of possibly events. They could be applied, as Sharon mentioned, in Persifasa, for example, the percussion piece that'll be played tomorrow. These a set of relationships that could create a rhythm, or they could create a scale. This is showing his sort of formal analysis of a major scale by using these basic logical operations. Essentially, there's not a lot of math to this. It's really just logic. But altogether, bundling all of these relationships together, you get this sort of unordered set of relationships that you could think of as intervals, time intervals, pitch intervals, or other kinds of intervals, maybe dynamic intervals or whatever. He actually worked out a sieve based on quarter tone, where the quarter tone is the unit, the basic unit for nomos alpha. So the cellist is playing scales that are based on a quarter tone sieve, and he went on to develop. Actually, he paid a lot of attention to pitch in later pieces. The one we heard today, Tetoro, is one where it, and lots of people, it sounds kind of modal. Well, he's using an ordered set of intervals, and working, and the material is the music is developed from that. And he did a lot of exploring of the possibilities, and in order to get different kinds of sounds, different kinds of harmonic, melodic sounds from this material that he didn't do in his earlier music at all. So when he started doing this, especially when it became more noticeable in the 70s, with pieces like Jean Chez, which was performed last year here by Esprit Orchestra, and then pieces that going right up through the pieces like that string quartet Tetoro that we heard today, where there's this pitch, the organization of the pitch material is primary to the piece. But this is how he's doing it. He's not using traditional scales. He's not using traditional harmonic progressions. He's deriving it from this kind of an approach. It allows him to explore a whole range. He can make these sieves as complicated as he wanted. They could be periodic, meaning they could have repetition. They could be aperiodic, or by having a period that was so large that you would never hear the end of it. And so, like, for example, the percussion piece we heard today, which has a, there are different sections, but you have a basic pulse, and then you have patterns over top of that pulse. That thinking, I mean, it is coming from this kind of an idea where I've got different patterns that are that are tied to a kind of basic pulse. In the case of rhythm, tied to a basic interval of unit, like a semitone or a quarter tone. In the case of pitch, and there's lots of possibilities. And really, this did shape Xenakis' thinking right through to the point where he didn't think about it formally anymore, like with the piece like Tatora. He developed some, if you read about it, he developed some, like, so I've got this sieve now, could I manipulate it? I could transpose it, I could invert it, I could, and change some of the numbers, so he called that a metabolae kind of a approach to manipulating and working with this material. Okay, I don't want to run out of time. We're sort of getting close to most of the techniques that he ended up then working with for the rest of his time. But he got interested in this idea of random walks, first of all, in trying to create a new approach to digital synthesis, and then he applied it to instrumental music. So in his book, he's got some of these. He was able to run some kind of, these are different mathematical functions, and given a graphic trace, he did a bunch of them to test them out, and then he tried to then say, what would happen if I sort of took this random walk kind of a linear process and apply it, and like map it onto an instrument. In the case of this piece for solo violin, it's all glissando, and it's really just, he's basically taking this random walk trace that he ran possibly on a computer, and then just transferred it into musical notation for the violinist to play. Crazy. Now, there are some composers who, where this would be the score, and you give this to the musician and let them play it. And so there's lots of graphic scores around, and lots of composers who have experimented with this. But this is actually my transcription of the score. What Xenakis did was write it out in musical notation. So he was not leaving it up to the performer to decide how far, high, and low they're going to go. He was writing that out. So it's precise notation, exactly what you're supposed to do. But it's coming out of this kind of a technique, a random walk, basically random walk type of technique. And he did this in a bunch of pieces. This is a different kind of look at that piano piece, piano piece where then the idea is this continuously fluctuating random walk could be mapped onto discrete events like notes on a piano. So his original score was all sketched out graphically, and then he was just taking his graph paper, mapping it onto so that a millimeter would be a semitone on the piano, and then so the music is transcribed into musical notation like that. But it was starting from these kinds of graphic shapes. Some of them he was doing intuitively. Some of them were generated, by a computer running some kind of random walk type function. And even in orchestra, this piece, this is an interesting sketch for a piece for piano and orchestra. One of the things that I find interesting is that in some cases these very same shapes are transcribed for piano where it's discrete, like you're just playing the notes on the piano, and the same shape is transcribed for strings where they're sliding, playing glissandi. So it's the graphic shape gives rise to two musics that actually sound quite different, even though it's the same generative material that looks like this. And of course, as Sharon mentioned this morning, at some point Xenakis then was able to develop the technology to be able to transcribe graphic shapes that could be hand designed or generated from running a function, and have them be turned into sound directly, like digitally generated sound. So his UPIC system was what allowed him to do that, and this was his. This was one of the element or parts of his piece from this first piece that he did with this computer system in 1978. And I think I'll just finish with, if you haven't heard this, this is, I think this is. So, just to finish, Xenakis then developed a number of compositional tools, some using probability functions, some using deterministic procedures, some and then coming back to probability type, like random walk type procedures, and in some cases combined with even graphic design where he's doing it by hand, sort of intuitively, and continued to work with all of this through the rest of his output. He as Sharon mentioned, he did subscribe to Scientific American. He did, we know that in the program notes for his polytope diatope from 1977, that he actually included a quote from an article in Scientific American about supernovas. So that was an inspiration for him in his multimedia light lasers and flashlight shows and so on. He was sort of inspired by that. Later, when I was in his class at the University of Paris, he had seen an article on cellular automata, which he talked about, and he actually used a little bit in a couple pieces in the 1980s. He talked about, I think when I was there, which was 85, 86, I think he sort of ran out of things to talk about at the end of the year, and he started talking about topology and using topological things to transform graphic shapes mathematically and so on, which I'm sure he applied in some of his music as well. But what is clear is that, and he mentioned it a number of times himself, was that having gone through all of this kind of formal work, that he was then able to basically work intuitively. That he knew without having to run programs and work it all out formally, that he knew how to get the results that he had explored through all of these techniques, and so his output ramped up quite a bit. He was a very productive composer, and considering how complex his music is, Sharon didn't mention, he's 150 pieces. There's I think almost 50 of them that are for orchestra. And none of them are simple. So there's a lot of work just to write out the notes of essentially one orchestra piece a year at least, along with lots of other music. So he was able to sort of work intuitively, but shaped by all of this sort of formal work that he'd done in the early part of his career. So I will finish there. Hopefully that's helpful. Thank you. Good. Yes. Although, in spite of me studying finite mathematics, the book, I never really felt completely comfortable working with probability functions and so on. But yeah, I have tried to apply some of this or related things in my own music, and I think I've been quoted. I saw it, or somebody had posted it somewhere that I said that I thought you could argue that all music is algorithmic in the sense that there's some kind of formal process going on, but often the composer isn't always aware of it consciously. But I have certainly tried to work on some formal techniques, and I use the computer as a sort of algorithmic compositional tool. But I guess I would agree with Xenakis in the sense that I never wanted to just do that. So it was a tool to be able to write some music, and I was much more interested in that when I was doing my doctorate, about the actual procedures and all of that. And now I'm just trying to get some music written when I have time. So, but yeah, absolutely. Just as what I took as a composer as inspiration was just, really thinking deeply about what music is, what musical form is, what they could be, and how you might think about working with those ideas. So yeah, I'd say very important for me, but not probabilities. Sadly. Any other questions? Do we have time? Glenn?
Not just work so much with mathematical probabilities, and I think you can see fragments of it visualize a lot of this stuff. He also said that we all know that if you listen to a lot of one kind of music, eventually the music starts to pick up traits of that. With his mathematical components, if his intuition start to pick up mathematical ideas and he can realize them without having to do all the calculations?
Yeah, I think so. That's what I take from, and he's said that. And he's also said, in order to really understand his music, you need to understand all of that stuff. Which, so he would talk about that. If we brought him in here, he would be happy to be scribbling probability functions all over the board and talk about that, because for him, that was how he thought about it. But he did get to the point where he didn't need to work through that in order to get a new piece written. So I think that's really interesting. I agree with you. I think he was intuiting sort of behaviors from having worked through it before. So and when I've tried to understand the music, I realized there's different ways you could get at that same result. You could do it this way, you could do it that way, and so it's, unless you have the sketches to know exactly how we did it, it's kind of like there's many different ways you could run some kind of process and get the same result or a similar result. Because one of the things that would be interesting to, is the relationship between, the processes, like let's say his most formal pieces, the ST, the computer generated ones, why didn't he just keep doing that? It would have been easy, just crank out more runs on the computer and write more pieces, and he didn't. So he chose to explore other things that were harder. I mean, other people have come along to implement some of these things, like the generating sieves and so on as computer algorithms. How can I put it? I think that it's an important process, but at the same time, I don't think that he felt like, well, if we just ran that again, it would be basically the same, because he actually did go through the results and decide, as you know, in the case of the ST4 piece, there's all kinds of really interesting compositional details that, as they mentioned, you know, like the transcribing the harp glissando back into, you know, a non-glissando, but a descending scale in the strings, when he could have, well, actually, you know, the original data said that was a glissando. Just, it was a really long one that the harp can't do at that speed, so it's just going to play, you know, a descending scale. So when he transcribed for the quartet, he decided that would be more interesting for musically, to leave it like that, even though he then has to also ask the cellist to tune down an extra octave, which is ridiculous. But there's many other sort of orchestrational things in that piece where he said, yeah, so there's this held note, but I'm going to score it for all the strings. So there's octaves and things that wouldn't have been in the original data. So he made all kinds of compositional decisions. So if you ran the data again, you know, it wouldn't be his piece, I think, which is interesting.
Yeah, that's precisely the provocation. You see, I think he used the language of mathematics as a structured form of thought, but I'm not so sure that the mathematical terms for Xenakis as terms of musical composition mean the same thing. I mean, I'd love to see a lexicon of the terminology, and I think mathematicians would be somewhat amazed at the definition, which isn't to take away from the mathematics, but to say that mathematics and arguably geometry will be shift into where I'm more familiar about in architectural composition. They are a point of departure, but they are not, in fact, rigorous rules. It's in the same way that an architect such as Palladio, who many neo-Palladianists would follow his rules, except Palladio never once followed the rules, and said, here's a structure by which I can begin my composition and begin to think upon certain issues. But in the case of architecture, the site's a little different, or the client had a requirement, or I'm feeling this way today, and what becomes a decision-making process. And I think this actually adds to the music. So I'm not arguing per se that it is, in a sense, weak mathematics, but to say that it is driven by precise mathematics, I think would be a mistake. And I think that's equally true of his work as, if you will, a structural engineer. That is much as driven by form. Or then, and you raised it, Sharon raised it this morning, you pulled Rally up on the screen, and we didn't really address it today. I mean, one of the, again, as a non-musician and non-mathematician, one of the descriptions of Rally has been, well, it's written for a pianist with 17 fingers. And, of course, the only way you can play it is to make the choices. But then, of course, Aki has 17 fingers.
Yeah.
Play the piece. But, so, I think we have to be careful. And maybe it's the lesson of so-called integrated disciplines. We borrow languages from each other, we learn from each other, but we still, in terms of creative expression, return to that, the media in which we're working, and which again is that wonderful balance way, and I think we described it. He uses the computer, but the computer doesn't become rigorously driving the music. It allows him opportunities to return to musical composition choice.
And I think that your comment applies to mathematics itself, where the point of definitions and the core discussions are all at the point of takeoff for intuition, which then leads to eventually new definitions.
Well, which would which, as I understand, is the foundation of the fields. You're one problem for the year, and you've got a number of people approaching it from a very different way, and suddenly find maybe it's not quite so defined.
What is the influence of Xenakis in today's music? The music that is composed now, how is that influenced by Xenakis' direction?
We need some young composers here. Okay, yeah. I mean, it's like being in France, and anybody younger than Boulez is a young composer, which is now anyway. I think quite influential. I would say certainly. Well, I'd say, as by way of example, look at the amount of activity there's been going on. Partly thanks a lot to Sharon's work, but not only exhibitions and conferences, but festivals, performances. His music is being performed an awful lot, and as Sharon mentioned, there's a lot of recordings out now. When I was working on my book, there weren't. It was actually hard to find recordings of his music, and still there's hardly any any of his really great orchestra music performed in North America. But yeah, I think, and it came up, like his percussion music. All percussionists play his percussion music. That's really, but for young composers.
Look at the last chapter of the Xenakis Matters book that I was showing this morning. I don't know whether you were here this morning. There are 10 contributors to this, which we call the chapter that we call applications. So it's applying Xenakian principles with creators today. And a lot of it, indeed, is maybe more tipping its hat to his interdisciplinary work, the polytopes, which we'll be hearing more about very soon. But also in terms of, the algorithmic paradigm and being able to embolden oneself enough to say, okay, this is what the computer is giving me. It's a little bit what David was saying, but the computer is giving me, but this is what I would want to do with it. I think his influence is very pervasive today. And thanks to the fact that there is exposure to his work, more than during his lifetime, both in terms of live performances and recordings. So the young composers who are going to concerts get a chance to hear it. I think it's really becoming part of the musical foundation for young composers. I hope so.
And further to that, Sharon, I add towards the synchronicity between, or the simultaneity of light and sound, which, if it weren't for Xenakis identifying those as a very intense conversation, I think it has contributed in so many ways to a range of media, including music, or the importance, for example, of sound in what I would call a post-cinematic world. But Xenakis understood both physics and conceptual physics and connectivity of the light and sound conversation, and I think the way that very few, if anyone, still has really demonstrated in this. It's really fundamental work to go back to that, to understand, not to repeat it. And Sharon knows this is an argument I've had with some of the Xenakis scholars who just want to rebuild the Phillips Pavilion or recreate the polytope. I mean, I think it's the last thing Iannis would want, because he said, wait a minute, look at the tools I bought now. Look what we can do. Look how we can move forward. I suspect, though it's not directly related, it's extraordinary of that.
Also happening with the DJ culture. Microsound.
Right. Yes.
Into that, but that has directly been affected by Xenakis and Curtis Rhodes. For many years in the 90s, you couldn't hear anything but granular sound from electronic music. Non-academic
Yes, and we'll hear that early granular piece tomorrow, concrete péage, which is the burning charcoal rather than computer generated, but very influential piece for that. Yeah, you're right. I think in the microsound world, it's a primary influence for sure.
Thanks very much. Let's perhaps continue the conversation a little bit later. And how about taking a very brief break now before the next talk? So let's start at 20 after 4. And have a very much. Thank you.